Right, good evening, everybody. Welcome to this first how-to that we're going to try and do on the webinar. What I'm going to do just before we start, just going to ask Mick if he can hear me okay. Everything okay there, Mick?
Yeah, all good, mate.
Thank you very much. Okay, I'm just going to run you through the sort of the control bar that you've got there, because we're going to try and do this a little bit of a different way. It's quite a small meeting. There's not many of us in here. A few more people might come along later on. But what we're going to try and do is, throughout this, if you've got any questions, we're going to see if you can ask the questions rather than wait to the end, like an open forum. Now, if you scroll your mouse across the screen, you should be able to come down. It's not letting me do it. Give me one moment. I tested it earlier and it worked. Let's try this again. Don't you just love technology? Right, there we go. Okay, so if you actually run your mouse over your screen, this pop-up bar comes at the bottom. Basically what you've got is audio settings on the side here. Now, if you click into that, if you're thinking about coming in and asking a question, what I will do is I'll ask you to test your speaker and microphone first. And I'm just going to put a highlighter on so you can actually see this a little bit better. So if you click that there, it'll give you a little test run of make sure your microphone's working okay and make sure your speakers are working okay. The speakers must be working okay, or else you won't be able to hear me. Okay. So most of us have found the chat and said good evening to everybody already, but if you haven't, or you just joined and not sure how to use this, if you click the chat button, this bar comes up on the side. Now it comes up as a default as all panelists. If you type into there, all you'll see is, sorry, the only people who will see your chat is going to be the panelists, which are myself, Mick, Stuart and Rich. Okay, but if you actually click the little arrow, you can change it to all panelists and attendees. Okay, so that way you can actually then chat to everybody in the room. As I say, if you want to ask questions just by text, text by typing, you can do that by clicking on the Q&A button just here, and you'll get this screen come up. You can type your question into there, and then Mick will be keeping an eye on any questions coming in. We'll try and ask the questions as we're going on. Okay, but if you actually want to ask a question, if we're going to try this, we haven't done it yet. We'll see how we get on with it, whether it works or not. But you can click the raise hand button if you want to ask a question. Click that up, and at the appropriate time, Mick or Stuart will bring you in and ask the question. They will turn your microphone on. Okay, so that's why I asked you to test your microphone first if you're going to do this. And you can ask me the question as we go. Okay. So when you click that raise hand button, it will turn green to show that you've got it up. If you've inadvertently clicked it or you change your mind, just click it again, and then the raise hand button will drop. Okay. So when it says raise hand, it means you want to put your hand up. When you've got your hand up, it turns green. There's another little thing you can do I've noticed on this one, depending on your screen. If you actually click the view options up here, you can change the screen size. So if it's not quite right for your display, you can change that around to whatever you want, make it look a little bit better. You've got fit to window, which is your default. Okay, and you can go into full screen, or you can exit full screen as well. So that's that there. Right, so you can have a play around with that for a minute. So I'm just going to come out of this and start at the other talk. So as I say, what I'm going to be covering tonight is just basic astrophotography to start with, and we might go a bit deeper on different nights, depending on how we feel we're getting on with this one. So, as I say, what we're going to cover is how you get some of these images. All these images on here you see are mine and taken with relatively reasonably priced astronomical equipment and cameras. Okay. So what I'm going to cover, I'm going to be covering photographing the night sky. So that's basically just, with a camera and lenses. I might then go on to polar alignment, just to show you what you need to do if you're going to go a little bit further with the hobby. And if we got time, depending on how we get on, I might just touch on imaging the solar system there. Okay. This day. All depends how we get on with the questions and answers and what sort of time. We're looking about finishing around about sort of 8 o'clock at the latest. This is only a short meeting. It's not a main meeting. It's just a little get together, and we can try and share some knowledge between us. Okay, so we're starting off. We're going to start with shooting stars. Okay, now, what do you need just to shoot the night sky? Stars, basically. Well, a digital or a film, if some people still like film, I mean, you can still get film, I believe. SLR cameras, a bridge camera, which allows up to about 30-second exposure, or ideally having a bulb setting where you can actually hold the shutter open. Okay. You'll need a tripod. If you're photographing the night sky, you can have in longer exposures. You will not be able to hold that camera steady to be taking any photographs. Okay. But most importantly, the one thing you're going to need is an awful lot of patience. Okay, because it's a trial and error, really is trial and error. I mean, I did start off doing this with film SLR, and the amount of film I wasted was absolutely unbelievable. It really was. But it was all worth it when you did get that one good shot. Okay, your worst nightmare is going to be light pollution. So say location, location, location is the answer. Get as far away from any streetlights as you possibly can. Because it's amazing, once you start opening your shutter for even 2 seconds, if you've got any light pollution around, it's going to spoil whatever you're trying to capture. Let's say this is an image I took back in 2015 down at the Bothy at the dark sky sites where Sigma go, whenever we get some clear skies anyway. As you can see, this was just a 30-second shot, and even that, this little light pollution here, you can just see it starting to come in. I believe that's Elgin over that way, if I remember rightly. So that's just the light pollution starting to creep in with just a 30-second shot there. It does give you an idea of what you can get with just an ordinary camera with a 50mm lens if you just hold that shutter open for a little while. Okay, this was untracked as well, so you're not getting any trailing. I'll explain a little bit later about shutter speeds and exposure times and everything like that as well, because it does make a difference depending on the lens you're using. So as I say, one thing you must do is find your dark side. Okay, if you're trying to do this in the middle of Elgin, you might have some success, but it just makes life very, very difficult. Okay, as I say, as it's May the 4th, may the 4th be with you. Okay, shooting stars. What a lot of people start off when they're getting into astrophotography is they try and do star trails, which is a good thing because you can, it gives an idea of setting around, you set your settings and what you're going to get from different settings and apertures and shutter speeds. Now, it just gives you an idea. This was a 285-second shot I'd done from my back garden. Now, the sky, believe it or not, was dark when I'd done this. But it just goes to show, once you've got that shutter open for quite a while, you're going to lose the darkness because it's going to drag everything through. Any bit of light pollution going anywhere, it's just going to lighten up. Okay, but there is ways around this, which I'll go into in a moment. To say, you can get star trails like this, and if you get something in the foreground rather than me just putting my tree and the lamppost in it, then it just makes it a little bit more spectacular to look at. But to say, there is ways you can get around not having the sky lighten up, due to your shutter being open so long. You can do it by taking individual shots and then putting them all together. And there's a little bit of software I'll show you in a moment of how that actually works. And as I say, the longer you leave that shutter open, or the more images you take over a period of time, the longer those star trails are going to be. And it's a stunning little thing to do, and it does make a nice picture on the wall if you get it good and get it framed. Always makes a talking point. So you can see here that this is in northern hemisphere, I'm pretty sure, because there is North Star just above the pointer there. So depending where you, there's that gone to. 1 minute. Yeah, to say the way that you can actually get these star trails without losing the darkness of the background, is this little program here called Star Stacks. What you do is take individual shots for whatever shutter speed you want, you know, whatever you're using. Just drag all your images into this box here, and then you click as a gap fill up there. Okay, so you make sure that's ticked, and then it will combine all those pictures together, and it will fill in any gaps there might be in between shots when when your shutter closes to when it opens again. It will fill up all the gaps and give you the lovely star trails. So that's a handy little free bit of software you can use called Star Stacks. It does other things as well, but it's really, really good for making them star trail pictures. And to say, depending whereabouts you are on the Earth, if you get closer down towards the equator, and you start taking these star trail pictures, you can then get to see both poles. So the southern pole down there, I believe, and it's going to be the northern pole up there, and you get this wonderful, wonderful transition of the stars going either way, depending on where they're coming around the equator. The equator is going to be running somewhere about here. Okay. Always worthwhile having to go with that if you go on holiday down south once we start flying again, anytime. And of course, there's always the chance to take the selfie. Everyone loves a selfie nowadays. So this is the one I'd done on that same night. I took the image at the Bothy. So once again, this is a 30-second exposure. But it's sort of looking a little bit of a different way, so I'm not getting as much light pollution coming into here. So it's in portrait, not landscape. So I'm not dragging it all in. You just go to show the simple things you can do just to make a shot. And if I'd actually had a torch and held a torch up to myself here, it made my profile look a little bit more, stand out a little bit more as a background. And of course, the aurora. This is always a favorite to be taken a picture of. So all these pictures I've shown you so far, the ones I've taken, all done with a 50mm lens, nothing out of the ordinary. But when you're taking a picture of the aurora, it can get a little bit tricky, because to say that the light is always changing, and sometimes you got to keep changing the actual exposure times and that, just to bring your aurora out a little bit. Very seldomly do you see the colors in your aurora with your naked eye, but the camera brings it out lovely. Absolutely brilliant. This was that massive aurora storm we had back in 2014 on 27th of February. To say it was absolutely stunning. Right above my house, that's the roof of my house here. Let's say that's the Pleiades. There's Taurus. So you're actually looking southwest here. So you can imagine how good it was. Really, really stunning thing. Most people have seen it, I think. Quite a few pictures around. I've not seen anything like it since, I must admit. Let's say the aurora always a good one to have a go at. And what you can do, if you haven't got a wide angle lens, which I don't have, this was another night. This was in 2013. I can't believe it's that long ago now, really can't. And I was out, say this is Baxter's here. This is the Fockerbridge bypass running up behind this bank. To say what I've done, I took 3 images, 1, 2, 3, all at the same settings. Now, if you are going to put these images together, then you must have your settings the same, as it just isn't going to look right. Okay, keep your aperture in the same, your exposure time and your ISO the same. Okay, and then what I did, I put these 3 pictures together in a piece of software called Microsoft Ice. Okay, I think there's something else you can do. So yeah, that's the light of Baxter down there, by the way. Okay, so there's much you can do, that can be done just with a camera and a tripod. But what I would advise you to do is to get yourself one of these. The shutter sort of release on a cable. Now you can get electronic ones or cable, and some of them you can plug you plug in via USB. The reason I say that, one is if you want to do any longer exposures, then you can lock the shutter open on the bulb setting. Okay, but the main reason is it eliminates any camera shake. When you press that button on the camera, there's always a little bit of shake. It's going to happen. There's no way you're not going to do it, no matter how good your tripod is. It's going to get a little bit of shake and just blur the image for maybe a millisecond, but it does make a difference. Okay. Let's say have a sturdy tripod as well. just the same with the telescope. It's only as good as the tripod. If you've got a weak, flimsy tripod and it's flipping around everywhere, once again, you can get shake, movement, a whole lot. And then you got another good handy thing on most of them nowadays is the spirit level. Because when you're taking photographs at night, it's very hard to make sure you're level to the ground, especially if you've got something in the foreground. You can take test shots, but it just helps. It just helps. I'm just going to touch on focusing here because this is what a lot of people have trouble with. When you focus, what I normally do, I have it set up on the tripod where I'm going to take the photograph. Now, if you've got like a distant lamppost, it's always good if you're on, and it's got to be distant. Okay. Turn your camera around to that. Get your your largest aperture, no, not aperture, sorry, your largest millimeter, and manually focus. Don't have automatic focus. It doesn't work at night. You've got nothing to focus on. You must have your lens on manual focus, and focus that the street lamp there. Okay, and then you can wind your lens back again to get your wider view. Okay. Obviously, we do try and get away from street lamps, so if there isn't any around, you can use a bright star, Vega, Capella, any of those, that you have a bright star, and do a couple of test shots to make sure it's focused. Okay. Much easier nowadays with the instant replay, and you can zoom in to make sure you got your star, your star, a nice pinpoint, you can always tell when it's out of focus because when you zoom in, it looks like a donut. Okay, just have a little fiddle. There's nothing worse than down a whole night taking images and you come back and every star is like a donut, or it's just fuzzy. It just falls a whole lot. And I say that from experience. Okay. Okay, and we're coming up to this time of year now. This is always a good one to start off if you're starting off with your astro imaging, noctilucent clouds. So they run between about May and July, sometimes a bit earlier, sometimes a bit later. What noctilucent clouds are, if you don't know, basically where we are with our latitude here, the sun never really goes very low below the horizon, and that sunlight will reflect off of the ice crystals in the sky, and we get these lovely what's called noctilucent clouds. Nocto, night, lucent, shining. Okay, noctilucent, night shining clouds. If you've never seen them, get out and hunt for them. It's a weird thing. They're not stationary like this. They move and shimmer. You can always tell when they're noctilucent because they're totally different to any other sort of cloud here, because this is just an ordinary cloud. These are the noctilucent clouds. It's almost like sort of corrugated iron sometimes, or corrugated steel. It's easier to get used to using your camera at night because it's still fairly light, so you can still see all your buttons and your settings. That's the hardest thing with astrophotography, is actually, as I say, making sure you know where every button is on your camera. Have a practice in the daylight, because once you get out in the night and you've got a red light torch going, it's very difficult to find the right button. Okay, if you then go and have like a zoom lens or a telephoto lens, your opportunities come out a bit more, but it does make it a little bit more difficult for focusing, I would say. And also you've got to start thinking about your shutter times, your exposure times, because obviously the longer the lens, the shorter the exposure time is going to be, and I'll explain about that in just a moment. But what you can get, I say, that's my 75 to 300 millimeter lens I use on my Canon. Let's say just down here, if you don't know, as I say, you've got your autofocus and manual focus. Always make sure you're in manual focus when you're doing nighttime shots. Auto is a waste of time. You say, remember I said about the bridge cameras, this is why SLRs are much better, because you can change your lenses around and it gives you more scope. So just with that lens, I got a shot like that. This was the moon in the daytime. Okay, let's say in June 2016 is when I first got that lens, and I thought, what am I going to do? It's not going to be dark now and for another 3 months nearly. So I thought, the moon's out. I'm going to have a go at that. So say that is the moon with a blue sky. I can't remember. Oh, yeah, 9 o'clock at night there, GMT. And have been BST. Let's go that way. Okay, so you get the moon, and that's just with a 300 millimeter lens, untracked, on the tripod. And the other night, when Venus was in the Pleiades, once again, that's just with the 300 millimeter lens, ISO 3200, f5.6, and a 2.5 second shot. And like I say, don't be afraid to have a play around with your settings, because sometimes you think, oh, that looks all right. Have a play around and just think, oh, what's happened there? And something will jump out. I've tried different exposure times, longer, shorter, and I found that this sort of exposure rate was quite good. Anyway, so we got to watch that as well. Like I say, it's quite nice now because I used to waste an awful lot of film, heck of a lot of film, to tell you the truth. Okay, so your main three settings on your camera are these. You've got your aperture. So the higher the number, the smaller the aperture, so therefore less light is getting into your camera. Depends what lens you've got. I think mine goes at the f2.8, I think it is something like that. So the lower the number, the wider the aperture, the more light's going to come in. So that way you can actually have a shorter exposure time. But that has to combine with your ISO, your speed rating as it used to be. Okay, film speed, if you remember that far back. And I say it runs normally from about 100. Let's say it's quite an old one now, up to 3,200. My camera will actually now go up to 6,400. I say I'm starting to use that quite a bit when I've got it attached to my telescope. Okay. And as it says here, start around about 3,200. Most astrophotography is done between 1,600 and 6,400. Okay. So you've got to have a few test shots, mess around with it, see what comes out. Okay. But obviously, as you're messing around with this, you're going to be changing your shutter speed to try and compensate for less light, more light, higher ISO or lower ISO. Now, obviously, as I say, your shutter speeds here, anything from 1/50th up to 1/1000th. You can have it handheld. It's good for freeze motion at this end here. Okay, but anything below this, you must be tripod. Okay, must be on a tripod, because if you don't, it's just going to blur. Because as I say, you're talking 1 second there. Okay, and let's say that shot I took was at 2.5 seconds. Let's say if I were trying to hold that still, it would just be a blur of nothing, waste of time. And once you start coming up here, most definitely. Okay, but you have another problem then once you start opening these shutters for too long. And that is the star trails. It's okay if you're trying to get star trail images, but if you don't want star trail images and you want a nice pinpoint stars in the, let's say in your photo, then you've got to go by this what's called a 500 rule. Okay. Basically, this 500 rule is if you divide 500 by the focal length of the lens you're using, okay, that gives you your maximum shutter time, shutter speed, exposure time. For example, I've written it down at the bottom here, exposure time, the focal length. Okay, so 500, if I'm using my 15mm lens, the maximum time I can have that shutter open is 10 seconds before I start getting trailing of the stars. Okay, and obviously if I've got the 300mm lens on, 500 divided by 300 is 1.6 seconds. So you're not going to get a lot of light in 1.6 seconds, even at 64,000 ISO or 6,400 ISO. So that's always a good one to remember, the 500 rule. And say, as it says here, if you're still getting trailing with that, move it up to the 600 rule. Okay, so I'll make the time even shorter. So let's go into some of the equipment you'll need if you want to go a little bit further. So I'm going to begin polar alignment as well for you. So motorized mount. You can use these, as I say, with that shutter speed. If you've got a motorized mount, it'll track the sky along your setup, right? You can, if you've got a motorized telescope mounting, you can use that, get an adapter for your camera on the top of there. Okay, it does need to be sturdy. You don't want anything blowing around and knocking around. Okay, so tripod or a pillar, whichever you want. Polar alignment, that's another thing you've got to think of if you're going to start using tracking. Okay, depending on the time, I may have a look into telescope or large telephoto lenses. So polar alignment, what you need to do if you were to remove the telescope here, or if you're using a telescope and attach the camera to it even, you've got to polar align your camera to the sky. Okay. Now, a lot of telescope mountings now have a polar alignment scope in here, so you can line up to the North Star. We're lucky here in the Northern Hemisphere that we've got a star to line up to. You've normally got a rectangle in the bottom of these that lights up, and by twisting your base left or right, gets it one way, and there's normally screws at the bottom here. I'll actually go on to the next slide. I'll show you a bit later on. You've got screws here that moves the telescope up and down that way. Okay. You can't go moving the tripod because you must have the telescope in this configuration when you're polar aligning, because I say you're trying to get that to line up with the North Star. Okay. And all depending how far south or north you are, that's either going to be higher or lower in the sky. So say, like those star trails there, the reason you get star trails, your North Pole is up here, and sort of Polaris. Every star in the sky is going to run around the sky following these arcs. Okay, and that's why you get your star trails happening as well. As I say, this is my telescope. I put this together when I was actually building the observatory, just to give you a better view of what an EQ3 mount is. Now, EQ stands for equatorial. As I say, this is an EQ3, EQ4 is a little bit better, so the number higher, the better the mount, and the more it'll hold. And I say that there is the polar alignment scope. So if I set the telescope in the right position, I can look straight through there. I say, just as I said before, I can line it up to the North Pole. Okay. And I say then once I'm away, it'll then track everything around the sky. So I say that it is a motorized mount. The motors are here. Okay. A little bit of equatorial mounts. Let's say EQ mount. There's two motors on it. Sorry, I should have done that earlier. Oh, I'll just go back and show you that. That's the actual image that I get through my rectangle at the bottom. Okay, and you just line up the pole star to that point there. Let's say by adjusting the two screws at the bottom, you can just see at the bottom here, or by actually twisting the whole plate left or right. So that's just another good church has a selfie shot of me when I finished off my observatory at home. Always time for a selfie. Right, I'm just going to go through different types of telescopes, and I'm going to sort of end it there. As I say, it's only going to be like a half-hour, 40-minute session. These, so I say, but if you're going to go a little bit further and you're going to think about attaching your camera to a telescope, first thing you've got to think of is what telescope you're going to use. Oh, so I just seen something pop up there after the chat. I'm sure Mick will let me know if anyone's got any questions. If you've got any questions, you know, you can put them in the Q&A there, or ask them at the end. So we're nearly at the end of this little bit. As I say, telescope-wise, you've got the Newtonian. Think about Newtonian. Really, really good light bucket. Now, my Newtonian is quite good for deep sky stuff, but it's not that good for planetary stuff. They're not really, they're okay, but there's other telescopes out there that are much, much better. Okay. If you don't know, the way your Newtonian telescope works is basically your light comes through here, and there's a mirror at the bottom, okay, and then the light bounces back up to here, to a secondary mirror, and then comes out your eyepiece here. Or depending on the eyepiece there is what gives you the magnification, what size eyepiece you've got. The smaller the number, the higher the magnification. And one thing about a Newtonian you must do, and I do it every time when I go out, even if this scope hasn't moved, is check the collimation. And that's a talk for another day, really. But basically, with a collimation, what you're trying to do is to make sure the light path is straight and everything's lining up. Because if you see there's springs at the bottom of here on screws, which will allow the mirror to tilt in 3 axes. So if the mirror is off, say it was off by coming the mirror out here, if the light comes down and hits here, it's going to come up this way. It's not going to hit your your secondary mirror quite right. Okay, and then the image will come over something here, so it's just gonna blur everything. You get an awful lot of trouble with that. But that's just something to keep an eye on if you choose to have a Newtonian telescope. And for some reason, it seems to have froze up again. I don't know why. There we go. Okay, refracting telescopes. These are quite good. As I say, they're much better for planetary actually, to give you a higher sort of magnification. As I say, these are actually using lenses rather than mirrors. So you've got a lens at the front, light comes down through to your eyepiece at the back. Okay. Once again, eyepiece at the back depends on your magnification. The lower the number, the higher the magnification. Just go to the little pros and cons of these a little bit later on. Okay, we've got the Cassegrain telescopes. Now these are really, really good, but also really, really expensive. They're sort of a combination of the two, really. They give you a long focal length by having a short tube. So the way it works is the light comes down. So imagine this is an outcut from here. So the light comes down. It hits your parabolic mirror at the bottom. And the light then goes back up to a hyperbolic mirror there. And then the light comes back down to your focal point where your eyepiece is here. Okay. So it's really good because you can get a long focal length with a very, very short tube. So you're not got like a 6-foot telescope to get the same sort of focal length. But as they are rather expensive. And most of them also come on this type of mount as well, which is the azimuth mount. I might ask a question myself for people who actually use these, because as far as I'm aware, if you want to start taking photographs of the night sky, you need to get a plate that allows it to track around the sort of equator. Okay, because the way these work is by moving left and then moving up or down, whichever way you're going, whether things are rising or setting. But I might be wrong, so I don't use that sort of mount, so I'm not 100% sure. So I say a few pros and cons. Here, basically with the refractors, yeah, they have a large focal length that gives you good high magnification, but also gives you a smaller field of view as well. So if you're new to this and you're trying to get your camera lined up and get everything focused up, it can be a little bit awkward. Chromatic abbreviation as well is not a problem. Depending on the quality of the lens, there's an image of it here. As I say, depending on the quality of the lens, a cheap one of these is a waste of time. You're just wasting your money. You've got to go for a good name, good brand name with these telescopes. You buy these cheap ones off the internet, that's a waste of time. Say, because even a good lens, it splits the light differently. Okay, and your red light and your blue light come into focus at different points. There are newer telescopes out now that compensate for this, but once again, the price does go up on them again. You'll notice if you ever use one of these, if you're looking at something like Jupiter or Saturn, the top Jupiter will be red and the bottom may be blue, depending on, say, how good that lens is. Okay, the Cassegrains, once again, a large mirror, good focal length, great light gathering power, fantastic light gathering power. Main drawback on these is cost. I would say they are very, very expensive. You're talking £1,000 start off near enough, apart from the smaller ones. And as I said, I believe you have to modify them if you want to use them for imaging. But someone might be able to tell me that software nowadays allows stars to be imaged and stacked differently. But I don't use that sort of mount, so I'm not 100% sure. But as I say, this one here, Newtonian, a good all-round telescope, relatively cheap. You would always get more aperture for for your pound from a mirror than what you will from a lens. Okay, you always get more and more aperture. So they're cheaper, but as I say, they're not as good for some of the planets and that, and they don't give you as much magnification. They're good light gathering power, really good for faint object galaxies, nebulous, stuff like that. Downside of these can be size and weight, and as I say, not so good for sort of that, planetary work. Right, what I'm going to do is I'm going to stop it there. Is that sort of 35 minutes? Because this will be another section for another day. As I say, we'll just go into how we then image the solar system using a telescope or a telephoto lens. Okay, everybody. So I'm going to stop the share, and if anyone got any questions, we'll see about answering them.
That was great, Peter. Cheers. I don't see any questions coming up. Just one thing I'd like to add, mate, if you don't mind. When you mentioned about the crop factors, sorry, the 500 rule.
Yeah.
The 500 rule with the calculations you showed there are only really for full frame cameras.
That's right. Yeah.
So if you have, what to remember is if you have a crop sensor like I have, you have, well, crop sensor Canon, you have to multiply your focal length by 1.6.
Right.
Yeah, before you divide it into the 500.
Okay. Yeah, I'm not you that sort of camera, so I don't know. You know.
Yeah, and if you've got for Nikon and Sony crop sensors, you have to it's 1.5 you multiply by.
Right. Okay.
Because your effective focal length of your lens when you put it on your camera on a crop sensor is 1.6 times the length of your whatever your
right. Gotcha. They say that's a newer sort of thing. As I say, with a bog standard sort of SLR, it's a good rule of thumb to give you an idea of exposure time to work from. You know, with a
but it does make quite a difference though, because if you take that as an example, your the 500 rule with your 50mm lens on a full frame sensor will give you 10 seconds, but on a crop sensor camera it'll only give you 6.25.
Yeah,
so it's quite a. So you will get. The thing is, at the end of the day, it's only a rough estimate. Anyway,
rough estimate. As you said in that thing, you know, if it doesn't work, you know, take do your test shot. If it doesn't work, make it 600. You know, so but
exactly. It's a lot easier now. You just delete the shot instead of wasting film.
I started with film and I had reams and reams of. No, that's no good. I got a good one there, and that was it. You know, so but
I would say a couple of other little things I would say. For anybody starting out would be definitely a red head torch.
Oh yeah,
for out in the dark. Yeah, if you use you can use a white one if you like, but then you can't see anything for another 20 minutes.
That's right. You're trying to focus. It's okay if you've got live view maybe, but even that, you know, if dark adaptation's gone.
Yeah, because I know when I started out with my old 350D, I went out in the dark down West Beach, and I hadn't a clue where anything was on the camera in the dark. Not a clue. I soon learned after that. Like, and the other thing as well is if you don't have a remote shutter cable, you can always use the delay timer on your camera. You can use it,
you can
use the 10-second one sometimes works. I suppose it depends how breezy is it.
I've just always got it there and just always use that.
Because
it's once again it's another button you've not got to try and find in the dark.
Yeah, I don't see it. There was a question from Martin, actually. He was asking, let me just find the chat. It was about Zoom, actually, though. Which setting are you using to get the screen layout so it looks good?
Full screen. I just go into full screen, I think it is.
Yeah, that's all I use. I didn't know there was different settings.
Well, as long as it looks good, that's fine.
it looks fine.
Yeah, Martin's got his hand up there, hasn't he? So... I mean, if you want to bring Martin in and let him talk, he can talk, you know, because I said there's only, what?
Hi, Martin, you can talk, mate. Oh, I think I've just pressed
Thank you. Twice. No, you did. Thank you.
Sorry.
No, it's all right. I keep it brief. We'll talk later because I really like the layout with your picture to the side and things like that, and I have the feeling that is not the standard layout, so you must have picked something, maybe even inadvertently. I like it. It would be nice to know.
Possible. I mean, the only controls I got here is the gallery view or the speaker view, and I've got it in speaker view at the minute.
Oh, it must be speaker view then.
Yeah.
That's what it is. Yeah. Okay. Super. That was all. And indeed, if you for the observatory we got a Cassegrain telescope, but what we did is indeed, if you've got one of those fork mounts, then you need to get what is known as a polar wedge.
That's it, yeah.
And now they are actually quite simple things, because what you do is actually you point the forks to Polaris.
That's right, yeah. But it's like I say.
So you need to. So you could actually even make something yourself. What you need to do is something that you can basically tilt at 47 point whatever degrees.
Yeah. Yeah.
And then you need to be able to rotate it till it points to and.
But as I said,
and nearly all of them.
It's still something else you've got to add on to your cost.
You do, but they are not cheap.
No.
But they are cheaper than those field D rotators that some people use because they are about as expensive as another telescope.
Yes. Yeah.
But
because I was wondering if there's any software nowadays that would actually, allow the stars to be tracked, in the stacking. So I'm not sure
absolutely. But the problem is you cannot take long shutter speeds because you get trailing, depending where in the sky you make your image. So you would still need to.
If you're taking the short ones, up to whatever you can, then be fine. But
but we never really had. There's two real problems with these stupid wedges, and that is there's a lot more load on the wedge on the gear on the gears and the bearings at the bottom end of the fork, and that actually broke.
Oh, really?
The scope, and then we put it straight up again because we didn't do any imaging, and now they got just a German mount for it that they permanently removed the fork mount from it, and it just basically got a couple of tube rings and stuck it on what is it, an EQ8 or so, one of those really heavy things. You need like 3 people to lift it on the pier kind of thing. But
say there's all these sort of pros and cons to them. They are good, but you got to think if you're going to use them for imaging, it's a totally different setup, isn't it?
Yeah. But very interesting, very nice. And I never knew about Star Stack, so I downloaded it, and it works indeed nicely.
It does work really well. It's a good little. I learned that from Magic actually when he was doing a talk for us. So super.
Well, thanks. Have a great evening further. Hi.
Thanks for coming on, Martin. That's great.
Yeah, I think that's it, Pete. I don't see anybody else.
Yeah, that's fine.
Questions?